Hello, Assalamualaikum, and how are you? I hope you are doing well in your place in your home or in your set. So in this video, we'll still cover the remaining of the inductance part from the chapter 3. But this time, we are going to cover the inductance of composite conductors. Okay, you can check internet what is the composite conductors. There's a lot of benefits by using the composite conductors. For this part, we are considering that composite conductors. Okay, in the relation of inductance, so solid round conductors were considered. However, in practical transmission line, stranded conductors are used. Here, there's two parts of definition here. One is solid and another is stranded. So what are they? It's very easy and very simple to be understood. So this is it. So this is the solid. Solid means you can see from the physical of the cable itself, it's totally solid. Solid, very tidy, okay, and very straight cut. And maybe if you try to hold it, maybe quite thick and hard. Okay, but for the case of stranded is looks like spiral. You can see a lot of cable a lot of cable are connected here. There's a lot of lines here, so we call it as stranded. Okay, stranded. Solid usually for the cable that's very hard. Okay, but this one usually most of the cases you can see a lot of any application, even from your plug, from your socket, from your devices, from your appliances. Also, they are using the stranded one, which is this kind of type. Okay, right. So for this case, so we are considering a single phase line. Okay, a single phase line consisting of two composite conductors, X and Y. So the first composite conductor is marked as X, and the second one is marked as Y. Okay, so the current in X is referenced as I into the page. Okay, so we consider the current flowing into the page and is I. Okay, I. While the another part, which is the Y part, so Y part we considering it written. Okay, the written, which is go back as the minus I. So okay, so one is the X is the, we assume in the normal direction, and one is in the written direction. So both are in the same magnitude of I, but with different direction. One is without minus, one is minus. Okay, there's I, X and Y. Okay, so conductor X, there's another condition here. So conductor X consists of n identical strands, okay, or subconductors. So in that conductors, they have strands. Strands, that's the stranded one. I mean, there are a lot of the subconductors. Sub of that conductor. So we call that as strands. So n is number, n identical strands, and each with radius rx. Okay, because the rx is the x part, so the radius for each subconductors is rx. Okay, okay. Then conductor y. Okay, for the case of conductor y, so conductor y consists of m identical strands. So we just change it from n to m to differentiate these two types of cable. So one is the M, okay, with the M identical strands of subconductors, each with radius Y. So each conductor have the radius Y. Okay, for the case of Y. Okay, sorry. Each conductor have a radius of RY, okay. But the maximum numbers, the identical strength is M. Here is N. Okay. Then, so what should we do? So since we have the two types of cable, so we just derive it from the original. So we are going to look for this is the total flux linkage. Okay, this is total flux linkage. So I hope you still remember that. So this lambda is the flux. Okay, flux linkage is the lambda. So we just add both for both cases. Okay, for both cases. So like I told you, because for the case of, so this is for the conductor X. Conductor X, and this is for conductor Y. Okay, conductor Y. Okay, so here they have the N here, and here is M, because we have mentioned before. While the distance between the second, still remember the distance between the first conductor to the side, and the next, from the B, from the C, from the C, from the E, from the E, F, G until the N numbers. Okay. Then from here easily you can simplify. Okay, simplify the this equation. So you take it out here, and then after that, so this definitely this we bring here. Okay, 1/n means the square, the root. So for this case is this one, m over n plus the minus. Okay, minus. Okay, so can we show as is? So m is here, and the n is over here. Okay. So from here you can simply simplify it. 4 minus and everything. Okay. And you get this. And after that, after that, since we get the lambda A, we have already get the lambda A, and then we find the inductance for the A, the conductor A, and then inductance for the conductor N. Okay, so it's very easy. You are going to divide it. Okay, divide it, lambda A divide with the I over N. Okay. Also, I forgot to explain here. So the current, sorry, I missed this. The current is assumed to be equally divided among the subconductors. Okay, like I told you, this part of current, so it's all current are I. Okay, the magnitude both, this one also I, but the direction is different. That's why I get minus I, but the magnitude itself is I. So for all, each current, for the current is assumed to be equal to all subconductors. That's why for each part of this conductor consists of I over N of current. Okay, for this case also, for this case it consists of, for each subconductor, the current is I over M. Okay, because we have the M numbers of the subconductors for the type of conductor Y. Okay, so that's why here for lambda A, the inductance of the subconductor A, so the LA, the lambda A is the same, but for this case it's I over N, because the current is I over N. Same goes with this, but this one is the lambda N, and it's the same I over N. So we are going to get this kind of because just divide it with the I over N, then the N bring up, so we get 2N, only multiply with N here. Okay, so it becomes here. Same with this. Okay, so then because the lambda A, that's why the left one is A, and A. Same goes with this one, A, and A. Okay, for this one, because the N, okay, the inductance is N, start from N, that's why this one N. Okay, let's go to N. Okay. Then what's next? So the average inductance. Okay, the average inductance, you can simply add all the inductance and divide with the number of strands on that conductors. For example, for this case is the conductor N. The conductor X. So they have the N strands, N strands of subconductors. So that's why the average one is the sum of all inductance obtained from the conductor X. So all, and then we divide with the numbers of the strands on that conductor X. Okay, then we get the average inductance. Okay, Then next is the inductance X. So we just put the X here, okay? Because we just want to we're going to pick any cable that conductors, maybe one of the subconductors that consisted in the conductor X. So we just get the inductance, then we divide to n. Okay, so the average is divided to n, then we get the LA plus LB blah 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 plus LN over n with power of 2. Okay, then next so next we are going to substitute the lambda A, the LA, LB, C, blah blah blah, LN into this equation. So means this value we substitute in. I just give you the LA and the LN. Okay, LA is not Los Angeles. It's the inductance of the subconductor X, subconductor A in the conductor X. Okay, so we just substitute it, and finally we produce this kind of things. Produce this kind of simplified version of the LX inductance of the X. Okay, I think we can derive. I think it's not that difficult. We can derive it, no problem. We can derive. Okay, what do we do now? So just in here. Okay, and so I take it out the 1 over n2. So we get Lx here is 1 over n2. Okay, then so for this case, I'm going to take only the first and the last one. I don't want to waste the time for the B, C, and D. Okay, like I've mentioned in the question, and the example, we have say like this, so this one is the M1 or N. Okay, then it's an A, B, C, D, and then we have the M. Okay, assume we have the A, B, C, D, 4 plus M, so we have 5. We have 5 strands here. So for the LA1, so for the case of LA1, so we have the 2n multiplied with 10 to minus 7. Then we get the ln. Then we have the M1, the M, and the one we have the N, where it is the D A prime, D A B prime, D A C prime, D A D prime, and D A N prime. Okay, let's see, we have the 5 strands. Okay, we have the 5 strands here. See, and for this case, we have the Rx prime. We don't have the DAA. Okay, we use it as the Rx prime first. Okay, then next the DAB, then we get the DAC, then we get the DAD, then we have the DAN, we have the DAN plus, okay, LB, LC, LD, but I just dot, so I just put here, so it's same to N, then 10 to minus 7, still the ln, and we have the M here for the upper part, and for the down part we have N here. Okay, then here we have the DNA prime, DNB prime, DNC prime, ND prime, again multiply with DN and prime. Okay, we have this. Then for this case, to make it better, so this is the DNA, okay, DNA, DNB, DNC, D and D, then we have the Rx prime. Okay, this is how we write the emitter. If we assume that we have 5 strands of A, B, C, D, and M for N. Okay, M for the case of, remember, conductor X, N for the conductor Y. Okay, so if I try to solve this, so I take it out here, I will get 1 over N, okay, 1 over N, to multiply with 10, oh sorry, minus 7, why is not out? Ln, okay, down here, you need to multiply, because this plus 2 and multiply with 10 to minus 7 for the case of B, C, and D. So that's why the most easiest way to write it is to do like this. Yeah, make it long. I did write by DAA prime, DAB prime, DAC prime, DAD prime, DAN prime. And we're going to have the, for the case of LB, LC, LD, then I just finish it at N. I skip the B, C, and D. So here we get DNA prime, DNB prime, DNC prime, DND prime, and DNN prime. Okay, right, over, okay, level N here. Okay, oops, sorry, oh, it's not coming out. Why? Rx, so D A B, D A C, D A D, D A N. Then skip for the B, C, and D case. So I just end up at N. So here is DNA, DNB, DNC, DND, and this is Rx prime. Okay, and we get this. Okay, but here, there's an assumption that we need to do. This one, the Rx1 will, for this case, it will become DAA for better simplification. For this case, it will become DNN. It also same goes for the B, C, and the T type. So it means that for the case of B, it becomes DBB, C, DCC, D, DDD, like that. Okay, so replace it with this value, and then we can bring, because the ln, we can bring here. Okay, it's okay. I just put the here is say this part I just put P, and this part I just put Q. By replacing this, means that it become now let's see, N, okay, N to multiply with 10 to minus 7 on, now it comes as MP over Q. So yeah, you know this, let's do exercise to remember what we have learned several years before. Okay, so it become like it's MP and Q, then we get 1 over N. So 1 over N itself is what? 1 over N itself is again I write it back to multiply with 10 to minus 7. Okay, ln, then it's actually the what? It's actually the root n. Yeah. So inside the root n, we have the m, p is, then we have the n, q. So, and thus we are going to get 2 multiplied with 10 to minus 7. Okay. Ln, okay, ln, get mn, mn, p, then we get the n with power of 2, q. Okay. Where the p and q you do it yourself. You paste it all this value, and paste this one here and this value is here. Okay. Okay. This is what we get finally. Okay, where? Again. Next. It come 2 multiplied with 10 to minus 7. Okay. Minus 7 ln. It come GMD. What is the GMD? Geometric mean distance over GMRx with the unit of Henry over meter. Okay, so the upper part is GMD, geometric mean distance, and the down part is GMR, which is the geometric mean radian. Okay, geometric mean radian. Okay, we have derived finally. Okay, succeed. That to derive. Maybe you say it's a waste of time for me. If we can derive, it means we really understand what it's all about. Okay, so told you again, rewrite it back. GMD is equal to mn. GMD with mn, and the GMR is n with power of 2. So the prime one is the mn case. Okay, the prime is coming. For the no prime is the GMR. Okay, it is it. I told you. I mentioned if we agreed already. This one, this one, and this one. Okay, DNE, the GNN and the DDB, DCC, DDD, okay, become RX. Okay, let's do some example here. I'm so sorry due to my change of my voice intonation. I think because I'm tired already. But okay, we need to proceed. Okay, guys, need to proceed. Okay, a stranded conductor consists of 7 identical strands or subconductors. Okay, so each of them has a radius of r. Means that we have these 7 strands: 1, 2, 3, 4, 5, 6, 7. So each of them has the radius of r. Okay, radius of r. Okay. The question is asking you to determine the GMR. What is the GMR? GMR is the geometric mean radius of the conductor in terms of r. In other words, your final answer will become like blah 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 r, like that. Okay, first of all, don't be panic. You just have to remember that we are going to use this kind of equation because they're asking the GMR clearly. So that's why we are going to use this kind of equation. Okay, give the power of 2 and then DAB. What is that? Okay. First of all, it's actually the DAB is the distance between 2 subconductors. Okay, for this case, you can start directly. You just start straightly. We find the D12. So D12 here, because the radius for each circle is R, so we get 1, 2. So we get 2R. Okay, 2R. Next, D17. Okay, D17 is also 1, 2. R also. And the third one is the D16. Okay, D16 is also 2R. Okay, 2R. Okay, 1, 2, 2R. Okay. Next is the fourth one. The fourth one, D15, D14, and D13. Looks like D13 and D15. There's some complication there. Okay, some complication there. I think I go for the D14 first, because D14 looks very straightforward, which is the 1, 2, 3, 4. So D14 is 4R. So next is the remaining D15 and D13. So it looks like the D13 and D15 from here, it looks like it's the same. length. So clearly it's here D13 is equal to D15. Okay, D15. Then, so in order to determine the D15, use your basic trigonometry knowledge. Okay, this is the triangle. So we know already D14 and we know also D45. That's why, so D14 uh, power of 2 minus D45 to the power of 2, power of 3. No, 3. Okay, D14 is the, sorry, 4R. The power of 2 minus D45 is 2R. 2R here. Then solve it. 16R2 minus 4R2. I think we still can simplify it. Okay, I think I'm going to take 4 out, 4 out, 4 out. Okay, I'm taking out 4R2 here. So we get the remaining is 4 minus 1. Okay, 4 minus 1. Then here we take it out. Okay, take it out, the 4R2 here to become 2R. And then the remaining 4 minus 1 is 3. So at the end, we rearrange it to root 3R. Okay, to root 3R. So what's next? Okay, what's next? Since we got already the D12, D13, 14, 16, 17, 15. So next is to do the GMR. Okay, the GMR here. Okay, GMR here. Okay, clearly they have the end, the number is 7, so 7 with power 2. And the root is coming here. So there will be go a very long journey here. Okay. Okay. The things that we have determined here is for the case of here. This is for the first strand. First strand means first strand. This is the first one. So this is for the first strand. Then this is our values n. So this n is 7. So means that the final one is the 7th strand. 7th strand. Okay. Means that we have another 2, 3, 4, 5 here. 2, 3, 4, 5 here, but later. Okay, later. Okay. First we solve the first strand. Okay, we are just calculated already. So the DAA is reflected to the R prime, that I prime. This is still remember R prime, RX prime, which is the here. For this case is the R1 prime. Then we are going to put the value of D12. Okay, D12 we already calculated, which is the 2R. Next is the D13. D13 we calculate also with the 2 root 3R. Then we have the D14, which is the 4R. Then we have the D15. Right? D15 brings you the value of 2 root 3R. Then we have the D16, which is the 2R, and the 17 also 2R. Okay. Now we get the first strand of all value of the distance for each subconductors for the case of first strand. Next, we are going to put the second strand also here. Then second strand. Third, fourth means in the middle, you're going to put the 2, 3, for second, third, fourth, fifth, and sixth strand. Which here, we need to calculate again. Right? Looks like we need to calculate again for the case of number 2, number 3, number 4, number 5, number 6. However, if you look from here, it looks like all for the case of 1, 2, 3, 4, 5, 6 is identical with the 1. It's all the same. I mean, even though you take from here, okay, if you start to calculate it one by one, it looks like it's the same pattern with the strand number 1. Means that if you try to calculate it manually one by one, we are going to have the same value with this pattern. Means that no need to do that. We just the power of 6. I mean, there will be 6 times here. Okay, I mean with the power of 6 here is enough for this, because first strand, second strand, and second, third, fourth, 5, 6 is the same value that you are going to get. Just the change of the D to 3, D to 4, and then for the third strand D3 4, D3 1, D3 2, but it's the same orientation of the values. with this value, we are going to get the same value exactly because the radius is all r. Okay, and then you just power it with 6. No need to calculate one by one. It's okay for you to go on. For me, just power it with 6. Okay. Next, but the difference is the last one, the 7th strand. Why I say the different? Because the 7th one is in the middle. It's clearly, it's not same with the others 6 strands. Okay, if I try to calculate, okay, D71, say I try D71, how much is it? This is D71, 2R. D71. D72 is 2R also. D73, 2R also. D74, 2R also. D75 is 2R also. And D76 also 2R. Means that we are going to get the 6 distance. That distance will be the same length of 2R. Okay, means that is the same relation here. I mean the DNN here. Okay, DNN here is the still R7 prime, but this time multiply with. So we have 6 distance with the value of 2R. That's why we come like this. Okay, the power of 6. Easy. Okay. So no need to calculate one by one. We just power it with the 6. Okay, means that if still remember this one, R1 is actually equal to R1 E power minus of 1 over 4, and this one is equal to the R7 E to minus 1 over 4. But however, since the R radius are R, so means that R1 is equal to R also, so become R E negative 1 over 4. This one also will become R E negative 1 over 4. Okay, if I try to rewrite it back, okay, sorry, I'm going to very long. Okay, power of 2. Okay. Sorry for my bad handwriting and bad drawing also, both. Okay, so now it become R E negative 1 over 4. I think I try to combine already. 1, 2, 3, 4, 5, 6. So we have the R power of 6. Okay, the R power of 6. Then I'm now simplifying the value from here. So I think I take out the 2, 4, 2, 3, 4, 5, 6. Okay, 6. So here we get 2, 6, power of 6. Then we have root 3, 2, double. So no need for root. This become 3 only. Then what's next? 2R. Finish. Okay, finish. So no more 2. Right. Then with the power of the 6. Then here we have the RE minus 1 over 4. Then we get 2R. So here also we get 2 with the power of 6. And then the R6. So we get here is R6. So now we try to, take up everything here. Take it out, everything here. Just simplifying here. So okay, R26 or R7, 42. Okay. Now we get I'm taking out the E minus 1 over 4 with the power of 6 will be multiplying. The power is multiply here. R now become R6 plus 7. 6 plus 1 becomes 7. Multiply with 60. We multiply with 6 become R42. And then what is next? 2, 1. I think I'm missing here. 1, number 2, 1, 2, 3, 4, 5, 6, 7. Sorry, this 2 is 7. Okay, 7. So means that I get to, I think I just remain 2 over 6 with the power 7 here. Why I take it out this 7? Because I'm going to cancel it with this the root 49. It's totally root 49. I can write just like that, but to make it the clear understanding, so 7 actually 7 multiplied 7. Okay, here is 7 multiplied 7. Can you see that? is actually 7 multiplied with 7. Okay, so I'm taking out the 7 so that I can cancel. Okay, and then 3 to the power of 6, then we get another one, R7, then we get E minus 1 on 4 here again. Whoa. Then 2 to the power of 6. Okay, so again I give 7 here. Okay, we can add up this one. Add up. So E to the power of 7. Now R become 42 plus 42 plus 7 become R49. Okay, very good value. Then 2, I think we just remain there. 2 6 or 7. Oh. Then 3 6. Then 2 6. Okay, now there's value that we can cancel here. Up. In that, now it become like very difficult to write. Very difficult to write. Sorry, maybe I write here. 7. Okay, 7. E from 49 now becomes 7 only. Then R taken out. Yeah, R is taken out. R is taken out, but this one is also the 7 one is remaining. So it becomes 6. Okay, 6. Then 3 become now 3 power 6 over 7. Okay, next the 2 also become same 6 over 7. Sorry. So sorry. Then the R is outside. Okay, R is outside. Can you see it? Sorry guys. 2 6 over 7. Here 6 over 7. Sorry. 6 over 7. Then solve it using calculator, and finally you're going to get the value of 2.17 1767 R. So you're going to get this value 2.1767. Okay, please try by yourself. Okay, please try. Okay, please try and we calculate it. So I hope you can get it. Okay, right.